Hello everybody. Today we continue the chemistry lecture Stoichiometry part 4 about limiting reactant. Let's have an example. These are tabletops. I have 2 tabletops, and I also have legs for tabletops. I have legs. So 1 leg, 2, 3, 4. I have 4 legs. I have 2 tabletop. Okay. If I want to make 2 tables, but we know that for 1 table, I need 4 legs. So if I want to make 2 tables, I need 8 legs. But I have only 4 legs available. So I cannot make 2 tables. I can only make 1 table, right? Only make 1 table. So I do not have enough legs to make 2 tables. So the number of legs is a limiting factor that I cannot make 2 tables. I have not enough legs. So legs is my limiting factor. Now in chemistry, for example, we have 2 chemicals react with each other. But maybe 1 chemical is too much, and the other chemical is not so much. Then the not so much chemical is called the limiting reactant. Let's have an example. I have lithium nitride react with water. And to produce ammonia and there is so to produce here lithium hydroxide. Just like what we did for the other parts, before today's lecture, we put down what quantity is given and what quantity we like to find. We are talking about reactant. So this is reactant, this is reactant. So for this question, we are not talking about the products. So this and this. I have 4.87. I have this many grams of lithium nitride. I also have 5.8 grams of water. Which one is too much and which one is not enough? Okay, so this is what we want to find. How do we do this? Because we are talking about gram, so I need atomic mass. So go to periodic table and find the atomic mass and find the mass of this part and find the mass of this part. That's the second line now. The first line is given. The second line is from the equation, from the reaction equation. So I need lithium, three lithium and 1 nitrogen. So lithium from the atomic table, 3 parts of lithium, and 1 nitrogen. This is atomic mass of lithium. This 1401 is atomic mass of nitrogen. So you do that. And so altogether you need to add and so the sum, the total is this much. Now remember, the unit of this is gram because the atomic mass is in gram. So gram. Now once I have the mass for this part, I can erase this, put 3483 there. 3483. So this is gram. Okay. Similarly, I want the mass of this thing, H2O, 3H2O. So I do that. H is 6. 3 here, 2 here, so it's 6H. 6H, okay, 6. H is 1.01 atomic mass. So this is 6.06. And oxygen is 16, and 3 oxygen. Now you add okay. 6 hydrogen, 3 oxygen. Add 54.08. Put this number below this, all right? And the unit is again gram. Now I don't need this. I can erase this. Okay. Similar to what we did before today, do the ratio. So this is gram over gram, gram over gram, then I don't need the unit. Use a calculator to find the ratio now. Use a calculator. And here, use the calculator. All right. Compare these two numbers. Which one is smaller? This one is smaller. That means I do not have enough water. So the water is the limiting reactant. Just look at the smaller number. This and this. You compare, the smaller number tells you this is the limiting reactant. Okay. This is a very simple way of doing it, okay? If you look at the textbook, it's more complicated. So I recommend my way of determining which one is a limiting reactant. Next example. Manganese iodide reacts with fluorine, produces manganese fluoride. Okay, so this is not 2, this is 3. And iodine fluoride. What is given? That's the next line. What is given, okay? I'm giving this many grams of manganese iodide, 25 grams of fluorine. So given quantity, I want to find how many grams I can produce. And another part is to find how many molecules I can produce here. How many molecules of this compound I can produce. So I can use Y molecules. Okay. I have this many grams of this compound. I have this many grams of this fluorine. My question is how many grams I can produce manganese fluoride and how many molecules I produce for iodine fluoride. Okay. Just like before, I have gram here, so I need atomic mass to find the mass of this. And from the periodic table, find the atomic mass of this. So let's see this now. 2 manganese. Manganese is this much, and 2 is 4, so 4 iodine. So I do that. And I add them together. I have okay. As before, I put this number below the given quantity. So all right. Again, I want the gram from this formula for this fluorine. All right. And 2 times 13 is 26. 26. 2 times 13 is 26. Fluorine is 19. So I multiply, I get that many. Now I put this number below the 25. Okay. So everything is in grams. I do the ratio just like before. I don't need a unit because gram over gram, there is no unit there, gram over gram. So use a calculator to find the answer. So the answer is this divided by that, the answer is 0.000022. And this one is compare these two numbers. The smaller one is the limiting reactant. So this is smaller. This is too much. I don't need this. Okay. The quantity of the products is determined by the limiting reactant. So this limits the quantity here, not this one. So I don't need this one anymore. It's this. Then I need manganese fluoride and 2 manganese. Manganese from the periodic table is this, and 2 times 3 is 6. 6. Fluorine is 19. So I have and this one is 114. So add again. I have two manganese. 2 times 3 is 6. 6 fluorine. Add. I have this. I put this underneath X gram. So 22388. So put this number underneath this. Divide, let them equal to each other, I can find x. X is 223 times 88 multiply 1.23 divided by this. So use your calculator to do this. Actually, you don't need to do like that because this divided by that is this number. Therefore, how do you find x? Of course, this is right. But to find x, is this number multiplied by this number. That's your x. So let's do that. So the x is so this is my answer. What is the quantity of the product, of this product? What is the quantity? How many grams? Is this many grams. It is this number multiply this number. Okay, that's for this part. Let me write this. X is equal to this. Okay, I can erase that. So I have one answer now. The next thing I want is to find how many molecules here for this one. To find the molecule, you don't need the atomic mass. What do you need? You need Avogadro's number. Avogadro's number. 4 times Avogadro's number is the number of molecules from the reaction equation. So I have 4 times Avogadro's number. This is Avogadro's number. So Avogadro's number multiplied by 4, 4 comes from here. Do the ratio. I can find y, because this is molecule and this is molecule. Molecule divided by molecule. I can erase this molecule now. This ratio is equal to this ratio. So this ratio should equal to that. So what is my y? Y is this number. Let me see. Y is this number multiply this. So I get y. So you use a calculator to do it. Y is this number multiply this. And my y is so this is my y. So this is the number of molecules. So molecules. Okay. So to find x, this ratio equals this ratio. That's how you find x. How to find y? This ratio is equal to this ratio. That's how you find y. So if you want to find how many grams, you use atomic mass to do it. If you want to find how many molecules, you use Avogadro's number. Okay. That's for today. Thank you for watching. Goodbye.